see how we can find the value of particular integral by using the method of undetermined coefficients. Now, this method of undetermined coefficient for finding this particular solution of the non-homogeneous equation is quite restrictive, because we can find the solution of the functions, or solution of these very little functions by use of this method. For example, only if the right hand side of the homogeneous equation have some exponential function or sine function or polynomial functions, or the combination of these functions, then only we can find the solution by using the method of undetermined coefficient. Let's see some of the functions where we can use this method to find the solution. For example, if we have some exponential function, for example g of x is equals to exponential of alpha x, then in such case, if alpha is not the root of the auxiliary equation, it means if alpha is not the root of exponential equation, characteristic equation, then we consider y of x is equals to some constant a times exponential of alpha x. If alpha is the root of the characteristic equation, then we use this x to the power k term, and multiplicity of k means what is the degree of the polynomial where alpha is the root. We will solve some of the questions, then it would be easier for us to understand this, but let's see through them. Now again, the second function is the polynomial function, which is in the form of a0 x to the power n, a1 x to the power n minus 1 in the same way. Then a polynomial of degree n, it is a polynomial of degree n, and if a0 is not equals to 0, then only we can find the solution of it, and the solution would be something like this. The same thing, but the coefficients has been changed. The coefficient has been changed, and if 0 is not the root of the auxiliary equation, we can use this. It means if a0 is not equals to 0. If 0 is the root of the multiplicity k of the auxiliary equation, then we again introduce x to the power k term in front of this whole polynomial, multiplying it, and then only we can use this as a particular integral and then find the solution. Again, the function third says if we have some kind of linear combination of the trigonometric functions, then only we can then also we can use the method of undetermined coefficient, and the solution would look like the same thing, but the coefficient k1 k2 has been changed with unknown coefficients a and b. Okay, if plus minus I beta are not the root of it, if these plus minus I beta are the root of the multiplicity k, then we multiply again with the exponential of k, x to the power of k. Again, if the function is the combination of exponential as well as the polynomial, then what we do here is the same thing that we have already did. If alpha is not the root of the characteristic equation, then we write exponential alpha a times the polynomial is the particular integral, otherwise multiply with the exponential or the x to the power k. Similarly, if gx, that is the right hand side of the non-homogeneous differential equation, is a combination where exponential multiplies the linear combination of the trigonometric function, then we consider the same thing as the solution, but we change the constants that multiply these trigonometric ratios. Again, if alpha plus minus I beta are the roots, then we introduce x to the power k. Similarly, with the polynomial times the linear combination of trigonometric functions, we consider same thing, but the changed. No, So now if we see here, we can find a little different kind of approach to solve such kind of questions. And here we can see that it is multiplying. It is the whole polynomial is multiplying firstly to the cos of beta x. It means this polynomial is acting as the coefficient of cos beta x, and again b naught of x to so b naught of x to the power n uh, is acting as the coefficient of sine of beta x. So it is a kind of uh, important case because it changes the format how it was like how it was in the previous cases. So it is quite important. Again, if these are the roots, then we multiply x to the power k to the whole solution. Okay, the same thing is here. Now we will see some of the questions, then it would be easier for us to understand what's going on here.